All right, so I've just set us up so that the screen can be shared by any of you. And Annie, I believe that you're first. So go ahead and take over. My guess is we'll get through the first 7 or 8 of these today, and then we'll move on to do the remainder of them on Wednesday. Okay? So what can you tell us about question number 1, Annie?
All right, I'm going to share my screen for my PowerPoint. Hi everyone, so my question is, can you guys see it?
Yeah.
Okay. So my question is, explain why we expect the return on particular capital component to be equal to the cost of that component. So I'm going to talk about the cost of capital and then the rate of return, and I'll show a graph and then my conclusion. So cost of capital, the Investopedia definition for it is the required return necessary to make a capital budgeting project such as building a factory worthwhile. So right off the bat, you can tell that the definition is almost the same as the required return. And there are multiple factors. First one is cost of debt, which is how much the creditor will charge for the given loan. And you can do this by calculating the total debt divided by the interest expense times it by if there's a marginal tax rate. And the next one is cost of equity, which is harder to calculate because of its uncertainty. Therefore, the cost of equity is the same as the required return for the equity investors, and you can use the CAPM to calculate this. So, and then once a company has an idea of its cost, equity, and debt, it typically takes the weighted average of all of its capital costs, and this produces the WACC, or the weighted average cost of capital. And then for the required rate of return, it refers to the return premium required on investments to justify the risk taken by the investor. So for example, a company willing to pay 5% on its raised capital, and an investor who requires a 5% return on their asset are likely to do business with one another. And this is these two metrics lead to the next point, which is opportunity cost. And opportunity costs represent the benefit of an individual investor or business misses out on when choosing one alternative to another. And it's easier to understand when you look at the graph. So this line right here represents the cost of capital, and this line right here, it represents the rate of return, and this is where it crosses. And I would argue the financial cost of capital, which is this line when it touches the cross point, is the opportunity cost. In conclusion, the cost of capital refers to the opportunity cost of making a specific investment. It is the rate of return that could have been earned by putting the same money into a different investment with equal risk. Thus, the cost of capital is equal to the rate of return required in order to persuade the investor to make a given investment. That's it.
Okay. So I see that I don't think that Ada is with us, and so she would not be prepped to ask a question about this. Do any of you have a question you'd like to pose to Annie to help explore this a little bit further? Well, I see that none of us ate our Wheaties this morning. And that we still have to put our boots on. So Annie, I'm gonna throw you the first one.
Okay.
Let's move back to your graph for a moment.
Okay.
So I see that at this point where they cross, but I also see that that point references the theoretical optimal mix of projects. What does that mean?
So the theoretical mix of projects is when you combine different projects So this graph is under when there's no budget constraint. So in the ideal world, or like realistically, that won't be the case. So most of the time it'll be, there's a budget constraint, and then there's another line for the budget, and then maybe cost of capital or opportunity cost will stop right here. And then you have to make sacrifice, or not sacrifice, or like decide which option is the best instead of choosing the mixed projects.
I get that. I understand what you're saying. I agree. I would also suggest that this same kind of graphic could be used to help us understand the optimal mix of capital components for a firm, because it lets us get to this point at which we've got our overall rate of return for the project and overall capital costs being the same. And while these clearly do touch on the subject, there's maybe a more simplistic thing I'd like to consider here. Can anyone else think of another relevant, in this case maybe yet more simplistic, way of discussing this issue of cost and return?
I don't know if that's that, but me, I was thinking about the point of view as we discussed in class, like from the investor is going to be a cost if you want to invest, and for the company is going to be a return, or vice versa. I mean, depend whose side you are.
Okay, and I agree with that, Alex. Let's look at that for a moment, though. I think I've given you guys the example of a bank, right? So let's assume that Annie is my banker, and I go to Annie to borrow $100,000, and Annie decides that her bank will extend that loan to me at a 6% interest rate. So my cost for that loan is 6%. Annie's bank is going to get a return of 6% on the loan, right? But is that expressly accurate, or am I simplifying this too much? Are there some other elements I'm leaving out of this discussion? Well, is Annie really going to get 6% on the loan? Or does Annie have to take out of that 6% transaction costs, the possibility that I might default, the time and talent of the employees that went about putting this together and validated my creditworthiness, the cost of the buildings that they're operating in? I'm going to guess that when it's all said and done, Annie's bank might have had a gross revenue of 6%, but lots and lots of costs are going to come out of that, such that what they end up keeping is much less than 6% on that loan, right? Because all of these other costs went into them extending the loan to me. The cost of monthly statements, perhaps. The cost of people answering questions that I might have on that loan as I'm 2 years into it, or whatever it might possibly be. So there are some other elements we might have to consider here. So when we say that cost and return are two sides of the same coin, and Alex, that's exactly, you presented it to us just like I presented it to you. That is kind of an overly simplistic way of looking at it, but it is the rationale behind us saying that cost and return are the same thing. It's the rationale behind being able to use R, which is a rate variable, and K, which is a cost variable, synonymously. Does that make sense?
Yeah, my question with that, Rick, is let's say you are the bank, right? And you want to get that 6%. Wouldn't you usually, so you do make your 6%, wouldn't you put those fees on, the company for the loan? Like, wouldn't you just tack that on instead of taking it out of your revenue?
Okay, I think that's a good question. So let's look at that for a moment. So let's say now that Annie's bank wants to net 6%. So they want to end up with, after it's all said and done, they really had a real return on this loan of 6%. To do that, they're going to have to charge me more than 6%, right? Oh, some of it they might charge in little individual user fees. If I'm late with a payment, they charge me a user fee. If I want to alter anything about the terms of the loan, if I want to find out early what it would take to pay it off, maybe there's a cost or a fee for doing that. But how do we build into this the cost of me simply making a call to Annie, or the cost of when Annie and her team decided whether or not to extend the loan to me? Well, we don't use individual fees on top of that. We charge a higher rate. And in which case, the cost to me and the return to them now become different, right? So we have to include these simplicities, maybe oversimplified scenario, in order for cost and return to be two sides of the same coin. But I think as business people, we have to accept that cost and return are only conditionally the same, but once other expenses, issues, elements come into it, then that might start to diverge. Good question. Annie, is there anything else that you'd like to add to this?
No, I think I'm good.
Okay, any other questions you guys would like to ask her? Okay, well, Alex, you're up. And Annie, you're the one that's going to have to ask Alex the first couple of questions. And Alex, you got question number 2, so that's going to, oh yes, the FCF and the KVD equation questions.
Can you see it now?
We can, but we were infinitely more interested in what was going on top of that mountain.
Yeah. So yeah, hi everybody. So today I'm going to talk about the APV model and the free cash flow model, and I'm going to tell you in what conditions they're ending with the same value. So first of all, let's take a look at the APV model. As you can see here, there is kind of 2 parts. So on the left part, that's the value of the free cash flow that the company will make. And on the right side, we can see the value of the money that the company will save thanks to taxes. Meaning that if a company is borrowing money, they will have a lower tax income, and then they will pay less taxes. So now we have that. We can also see that the left part looks a lot like the free cash flow model, except that we have KU instead of the WACC. So we can assume that we kind of want to have the right part of the equation equal to 0, and then we will have the APV equation equal to the free cash flow equation. So let's take a look about the variables in this equation, and I highlighted some in blue. That's the variable that I believe we cannot really play with, because the free cash flow, if the free cash flow is changing, it's going to change in both models, so it wouldn't have any effect. Same with the G, and then 1, I mean, that's a constant, so we cannot play with it. So we can play with KU and K tax, or with the tax shield. So let's first take a look about KU and K tax. So KU, that's the cost of common and the cost of preferred. And K tax is the cost of debt. And we can see that there is a relationship between them. In fact, if one is equal to 0, well, the other one will be the WACC. So what I mean is that if a company does not have any debt, then the cost of equity will be the WACC, and vice versa. If they don't have any equity, the cost of debt will be the WACC. Now let's talk about the tax shield. So the tax shield is the tax rate times the interest expenses. And as we can see so here you have the, I'll do like that maybe. Here you have the right part of the equation that we saw earlier. And as I told you, we kind of want it equal to 0. And to have this equal to 0, we want the numerator equal to 0, meaning that we want the tax shield equal to 0. And how can we have the tax shield equal to 0? Well, there is 2 possibilities. We can have a tax rate equal to 0, I don't think that's possible. I mean, I never seen a country with a tax rate of 0%. So that will be having interest expenses of 0. So having a company without any debt. And if the company does not have any debt, then the KU will be the WACC as we saw earlier. So here is the APV equation that we saw earlier. So now we have, let's say we don't have any debts, so we don't have any interest expenses. So we have this equation now. And as I told you here, now KU is equal to WACC, so we can change this equation to that one. That one is the free cash flow model. So in conclusion, there is only one possibility to have the same value with the APV model than with the free cash flow model, and that's if you have a company without any debts. Thanks for listening to me.
Well, that's very interesting. Hey, so before you ask your questions, let me remind you guys that some of the questions on the sheet overlap with other questions. So what we're talking about right now is going to be rehearsed again in some respects Wednesday when Chenjiang discusses KU, K-Tax, KE, KD with us as well. I already know he's going to take a different tact on it, so this is good. So just remember that. So that's purposeful in these things. So Annie, what questions would you have for Alex before I have some?
Okay. So my question is, so if a company doesn't have, if the company has debt, then which model is better to use?
I mean, that depends of everybody. I would say that might be interesting to use the APV model since as I wrote here, like the APV model, the good part is like you're taking in consideration the cash flow, but you're also taking in consideration the money you will save by borrowing money, because you will have a lower tax income. So I don't know, I would say if you're using a lot of debt, it might be a good idea to use the APV model, but that's personal.
Okay.
Any other questions before I jump in? So Annie, to kind of go along what Alex just said, I would say if the company has no debt, then there's no reason to use the APV model. It's just a more complex model, right? And so if no debt, don't use the APV. And that's just right off the top of your head. Alex, I think that what you pointed out certainly is accurate. Okay. In fact, KU would be equal to WACC if there's no debt, which means there's no RD, and which means that the company's equity is unlevered, and the U stands for unlevered equity, right? But I got to admit to you that under the conditions I've thought of in the past, I really haven't thought of it the way that you did. I took a completely different tact on this. So I appreciate you thinking of it from that standpoint. But even under your condition, there's at least one other option. Can anyone, or one other way in which these two equations could equal the same values? Can anyone else see another scenario here, kind of along the lines of what Alex was talking about, in which these could be the same, in which case the second half of the equation would be zeroed out?
I was wondering about like limited liability corporations that don't have tax.
Okay, that's a good question, Megan. So a limited liability company, or LLCs, some of you realize, the entity itself is not taxed. Any profit that the entity has at the end of an accounting period is then allocated to its partners for taxation, in which case the entity doesn't have the tax, but the partners do. And you could still apply the APV model, but you'd have to use a tax rate of some kind. And under the premise that the ownership structure of the company shouldn't have an effect on the value of the company, you would still use the theoretical tax rate that a company would pay even though you know that LLC doesn't pay tax itself, okay? So we can't ignore this issue. But what if the company had debt, so plenty of interest expense, but what if there was no taxable income? So we got to the point where taxable income was zero. What would be the value of the tax shield if taxable income is zero? Well, how do we calculate the tax shield, Alex?
Like, so we calculate its interest expenses and tax rate, but yeah, maybe, I don't know. I have to admit, I don't know if we're taking the tax we paid like last year,
Okay.
or if we're taking I mean, I don't know. Are we
Well,
taking
on this, we're always going to use the tax rate on taxable income.
Okay.
But so if the company has a zero taxable income, it's not going to have a tax liability. It's not going to have a tax rate, right? In which case the tax rate would be zero. So the interest expense times zero equals zero. And all of a sudden, the right-hand side of the equation is zeroed out just exactly as Alex has shown here, for a different purpose, by the way. The reason that Alex zeroed it out was assuming there was no interest expense. I will tell you that it can similarly be zeroed out if there's no taxable income, but even if there is interest expense. Does that make sense?
Yep.
There's yet another scenario. Alex, can you put the entire equation up for a moment? And are you able to, do you have something that lets us see both equations on the screen at the same time?
No.
Okay, that's fine. That's fine. I'm going to go ahead and release the screen to me if you would, and then I'm going to share. Because as it turns out, I have this right here. So we're looking at the equations right here. So I believe in one of the problem sets, I allow you to consider the various Ks, these costs, KU, K-tax, etc., as being equal to WACC. And I did that in that case simply to make it easier for you to come up with values. But when you came up with values, the outcome of the APV model and the outcome of the free cash flow model were very different, weren't they? Premise being that we can't have part of an equation equal the whole equation, unless, as Alex said, the other half is zeroed out. So if we're just looking at this first part, if KU is equal to WACC, then this first part of the equation is going to come up with a number. And if there is a tax shield, then the second part of the equation is going to come up with a number. And you're going to add those two numbers together. And they can't equal what this equation equals, because this equation is kind of embedded into this other one. So we can't have it that way. So how would we have it? Well, we might argue that KU and K-tax, A, don't equal WACC, and B, don't equal each other. Now, Shenzhen's going to talk more about some of this when he addresses this with us on Wednesday, so I don't want to go too deeply here. But think about this. If KU and K-tax were different values than WACC, could this APV equation end up equaling the free cash flow equation?
I know that I tried, like on the Excel model, to play with the KU and K-tax to have the same number. And I was very close to have the same number. But I don't know, it didn't look realistic to me when I was playing.
And did you have KU and K-tax equal each other but be different than WACC, or were they each different from each other and different than WACC?
Different from each other and different than WACC.
Okay. So let me tell you that in practical terms, that K-tax is more often thought of as being equal or nearly equal to the cost of borrowing, or KD, okay, which is same as RD. And that KU is more equal to the cost of equity. And when you take that, if you substitute KU for RE, and if you substitute K tax for RD, then you get closer to these two equations having similar outcomes. But even then, you're only getting closer. So there's some other adjustments that might need to be made. Normally, if you looked at this critically, you're going to find that K tax is almost always lesser than KU. Well, one of the reasons for that is because we don't like to pay taxes, and we always want to think the opportunity cost of doing so is low. Otherwise, we get frustrated by having paid taxes sometimes. And we think that equities should always return more than debt. But is that necessarily always the case? Or are there conditions and markets in which debt returns more than equity? Look back at the 1970s when interest rates were double digit and deeply so, and the stock market was struggling. Well, you made a lot more money by holding bonds. So RD was much higher than RE at the time. So you've been raised in this world in which debt is cheap and stocks provide great values. And I like that you've been raised in that world, because you've been raised in the years that I've been accumulating, but that's not necessarily always been the case. And it won't always be the case. It just happens to be the scenario that our economy has evolved to at the moment. So I would say that there are three ways, and these might equal the same number. Alex pointed one of them out: if the company has zero debt. I pointed one out: if the company has no tax liabilities, so it's got zero taxable income. And then a third scenario is when KU and K tax don't equal WACC, and then we have to think about the conditions under which KU is greater than K tax or K tax is greater than KU. Now, along about this point in the discussion that we have as we prepare for the exam, you guys are probably sitting there thinking, okay, some of this makes sense to me, some of it doesn't. And by the way, I would recommend you go back and look at the video on this sometime before you actually take the exam. But your task is going to be to take all of this stuff from the presentations, from your mind, from the questions, from what I'm telling you, and compose a credible response that is structured well enough to make sense. There's a lot more that we've said in the last 10 minutes about this equation than you are going to be able to write. You just can't write all of it. And certainly in the amount of time that you're going to have available to do so, right? So you're not going to be able to give a absolutely complete response to some of these questions. Oh, some of them you probably will, but some you won't be able to give an absolutely complete response. Your role is going to be to give a credible response that makes sense, and that I can tell you have thoughtfully considered the question at hand and the answer to it, and spend some time trying to craft it in such a way to show me that you understand what you're talking about. That's your role here. Because there's probably, well, as we just pointed out, there's three completely separate conditions. Alex gave you one, I gave you two others, and you're not going to type all of that up and do a good job. Well, that's what, 4 or 5 pages? You're not going to do that. But you're also not going to give me 1 or 2 just very simplistic lines. Okay? All right, so who's next? Oh, Brandon, you're next. That's why you're dressed up today. I figured you either had just interviewed for a job, or you were going to the bank to borrow money, or you were trying to impress us. I figured it was one of those
I just had a hunch that you were going to call on me today, so I decided to, present myself.
You are the man. You are the man. I don't know that I believe you, but you are the man. Okay, so let me go ahead and unshare this. Where is my share? There it is. And Brandon, you can go ahead and take over.
Oh, perfect.
And then Alex, you're going to be the first to ask a question.
Awesome. Can you guys see that? Is it working?
Yeah.
Okay, cool. All right. So question 14, why is free cash flow? I got to move this. This is bugging me. All right, perfect. Why is free cash flow the preferred cash flow variable used in asset valuation modeling? Let's see here. Kind of going through it. To kind of start off, I thought, when I was going through it, I needed to look at a list of what are the other variables that we use in asset valuation modeling. And these are asset-based. There are also some that we've covered that are also equity-based, but all the ones below, some carry over with equity, and most of them are all of them are asset-based. So there's a list of them right here. Now, I thought to kind of really iterate and answer the question, it's good to review exactly what free cash flow is and how we can use it in an example. Free cash flow represents the cash a company generates after accounting for cash outflows or reinvestment in non-current capital assets. Free cash flow can provide important insights into the value of a company and the health of its fundamental trends. And there's probably other, as we've kind of covered it and had our class discussions, there's other ways that you can define free cash flow, but this is kind of the one that I came up with while doing this, but I'd love to hear from you guys and see if there's any other ones that can help us understand free cash flow. So as an example that kind of thought of was, free cash flow really helps us be able to get the insights of how a company is doing or being able to pull value from a company. So like, for example, if a company had made about, $100 million per year in net income for the last decade. On the surface, that looks great and stable. But if the free cash flow for that company had been dropping over the last 2 years, as for example, maybe inventories were rising, customers started to delay payments, maybe vendors began demanding faster payments from the firm. In this situation, the free cash flow would reveal a serious financial weakness that wouldn't have been apparent in an examination of the income statement alone. Also, free cash flow is also a helpful starting point for potential shareholders or lenders to evaluate how likely the company will be able to pay their expected dividend or interest. Going a little further, here are the equations that we've covered that kind of give us what free cash flow is. The no plat plus no cash expenses or depreciation, minus change in net working capital, minus net capital spending. And the first two usually yield the same result. The one on the bottom usually doesn't give you a different value, but we all are really familiar with the top one, of course. So to answer the real question, so why do we prefer using FCF when creating valuation models? Among all the discounted cash flow models of FCF, KBV, APV, and so on, those using FCF as the cash flow variable are most commonly used by analysts and practitioners. Investors, creditors who need to evaluate a company's expected performance with different capital structures will use variations of the free cash flow, whether it's free cash flow for the firm or free cash flow in regards to equity. Reliability. Free cash flow is considered to be in some way more reliable in performance measure than other income variables. It's also reflective of the cash flow form for which the owners of the firm's capital structure hold future rights. With that, free cash flow can also be separated and evaluated into different parts to point what is possible to focus specifically on operational structures of the firm. So what I mean by that is we're able to, like I said in the example and in the definition, we're able to pinpoint specific weaknesses or strengths that a company is experiencing with production or with operations. The last two, it reflects the firm's capital structure. It is reflective of the cash flow form for which the owners of the firm's capital structure. I already said that part. So I guess, so the last one obviously would be calculation of the firm's value. I think that kind of gives a whole conclusion on what we're talking about. And I think that right there is the biggest advantage to this approach, which it allows for the calculation of a firm's value based on that which the firm produces for its debt and equity stakeholders. So, and that would be it.
Alex.
Yep. So I have a question because I kind of agree that the free cash flow model is pretty easy to use, and maybe that's why also like is preferred. But don't you think that it's too simple, the free cash flow model? I mean, because I was like kind of thinking the same than you, but then as we went through the APV model, for example, I kind of changed my mind on that. So what do you think? Do you think people are using it because it's very like it's easier and it's faster, but they're missing a lot of details by using it, or do you think it's enough with the free cash flow model? Like you have enough details?
Yeah, I would say yes on the idea that it's fundamentally simpler. It's also, I think, universal. It gives each model, and I think that's why each model uses it, because it can work within each model. And I think when you're getting down into specifics of certain things that you want, that's why we would use the different models. Correct me if I'm wrong, Rick. And so, but where is it going with that one? I think that's kind of, yeah, I guess just saying that it's simpler and being able to give every model a base number, a base idea to work off of.
So I would tend to agree with that. But let's look at this from a fundamental standpoint. If the APV model, when using the appropriate values for KU, K-tax, KD, etc., should equal the free cash flow model, it really becomes irrelevant as to which one you use then, because you should get the same outcome, right? That would make sense. And we all know now pretty well how to calculate the weighted average cost of capital. We all know what we need to do when we have to take into account an investor's required rate of return. But as was pointed out a few minutes ago, the concepts of KU and K-tax, and again, Shenzhen will talk about this with more detail on Wednesday, they are somewhat more fleeting and ethereal and harder to get our head and hands around and put into an equation than RD, or rather an investor required return, or the company's weighted average cost of capital. And because of that, I will tell you that I virtually never see valuation analysts ever use the APV model. It is so rare, and even stock analysts and such working for different firms will rarely use the APV model. Sometimes companies will apply it to themselves for particular reasons, but more often than not, they won't. In fact, we most often see two models used. We see the free cash flow model, or some slight variation of it that I'll explore here with you in just a moment, or we see a multiple being applied directly to the company's cash flow, or one of its cash flow elements. Not even something with the significance of the FMM. Simply going from, okay, what's the company going to do next year? And we're going to multiply that by the multiple, and we're going to call that the value. So those are the income approach, discounted cash flow, free cash flow model approach, and the market approach using a comparable multiple of some kind. But let's back up and look at a couple of other items here. Could you go back to where I can see the equation? Let's start this one, and then we'll look at the model equation. Yeah. So I think when you're answering these questions that you're probably well served to help me understand the inputs to the equation. And Brandon's done some of that. He's given us the equations. In fact, he's given it to us in 3 different forms. He's even noted here which forms should yield the same outcome and which forms are likely to yield different outcomes, okay? Which is good, and that's probably incumbent upon you if you're trying to give me a full-throated response on this. But in this case, I would maybe go in and discuss a little bit further what the equation's inputs represent. So no plat is EBIT, or our operating income, times 1 minus whatever our tax rate on EBIT. Non-cash expenses would be depreciation and amortization. But then what is maybe even more interesting is this issue of change in net working capital. And I like how you described some of that, Brandon. And then change in net capital spending, which you didn't actually go into any description on, but we have to think about that. See, it's those parts of free cash flow that most people don't get. If we didn't have a change in net working capital to think about, if we didn't have net capital spending, then frankly, the first part of the equation, no plat plus non-cash expenses, is simply a tax-adjusted EBITDA, right? Because no plat is EBIT times 1 minus tax rate, and the non-cash expenses are DA, depreciation and amortization. So the first part of this equation is simply a tax-adjusted EBITDA. It's the second part of the equation that really causes people to run into trouble sometimes when they don't consider it. So let's assume for a company, or for a moment, that Jaden's company, Jaden, you may want to come off of mute for a second. Jaden's company has made a commitment to extend terms of a lengthier time frame to customers next year than were extended this year. And he chose to do so in order to make it easier for them to buy product, which also meant that he was going to have to probably extend out how long it takes him to pay his suppliers. Okay? If you've done that, is it important to think about free cash flow rather than just EBITDA, Jaden?
Yes.
I was hoping for more than a single syllable response, you dog.
So that's going to change your net working capital, and I think it's just indicative of the fact that you're likely tying up more cash,
yeah,
and able to cover extending more gracious periods.
You're exactly right. You're tying up more cash, and that's the point, because we think of profit or EBIT adjusted for tax, EBITDA adjusted for tax, we think of that as being the money that we get to use as business owners, right? But it's not. It may have a reflection of our gross revenue and our expenses, but the money we get is a function of the cash flowing through the company, which includes decisions made by us in terms of cash management. It includes decisions made by our customers when they finally get around to paying us. It includes decisions made by us as to other things we're going to invest in. So let's move to net capital spending. So Megan, your company is looking to expand into another marketplace next year. And you've got, in fact, I'll let you come off mute so you can help us here in a second. So, and you've already started this process some. You know it's going to cost you $10 million this year, $20 million next year, and another $40 million the year after as you finish the marketing campaigns, hire the people, build the facilities, whatever it's going to take for you to expand into other markets. You need to know that in order to know what the value of the company is, don't you?
Yeah, I think it's similar to what Jaden said, where if you're spending money on all these things, it'll probably help your value in the future, but it's tying up cash right now.
You're exactly right. And maybe it's not tying up cash right now, but it's a commitment to tie up cash, right? So when we think of free cash flow, we not only think of operating income adjusted for non-cash expenses and tax, but we also have to think about other places that we've committed our capital. And sometimes those commitments aren't exclusively made by us. Sometimes they're a function of our customers, either not buying or not paying from us on time, or maybe a function of our vendors asking us to pay earlier or letting us pay longer. So it's all about the amount of money we have and how we've committed it. So think about that. Think about wrapping that into your discussion. You might also want to consider, and this touches back on something that was referenced a moment ago by Brandon, but I don't think you realized he was discussing it. He talked about money available to the shareholder, money available to the owners. Well, think back to something you learned in Finance 300, and it's how I introduced free cash flow to you, and that was CFFA, cash flow from operations, or from assets, cash flow from assets. Remember, there were two forms of CFFA. What were those forms, basically? Does anybody recall what was behind those two forms?
Operating cash flow, net capital spending, and net working capital.
Well, and that was CFFA 1, right, Will? And that was, where does our cash flow come from and to where do we commit? The other one was CFFA 2, which is cash flow to creditors and cash flow to other shareholders. So CFFA 2 is, where do we commit our cash flow? And those should equal the same thing. Okay, so you might want to think about that as well. Any other questions or points on this before we move on to Fred? Okay, so if you could unshare for us, please, Brandon, and Fred, we're going to let you take over.
Alrighty, let's make sure I got this. Share screen, share, boom. That it?
Yep, there you go.
All right, so the question I have is, explain the difference between FCF and the FMM models, the functional difference, and why one is used instead of the other, why we expect similar outcomes, and why outcomes are similar or different. So I just pulled up the sheet that you created, Rick, that has the equations here, and we can see that right here for the free cash flow model, and down here for the FMM model, the explicit period equations are actually pretty much the same. And then if we look over at the continuing value or continuing period equations, that's where they differ. And the FMM model down here actually looks a lot more simplistic, but it actually isn't. So the main difference that I want to start on is the actual inputs. So for the FCF model, the inputs are pretty much just FCF, which is no plat depreciation minus change in net working capital minus net capital spending, our long run growth rate, and then our WACC. But for the FMM model, we actually have a lot more inputs because we have to find FCF. Let me pull this up 1 second. So we have to find FCF, EBIT, and then no plat, invested capital, ROIC, and then also use WACC. So that's how they're kind of structurally different in the continuing period, because the equations for that are different. And if we're looking at the question of why one is used instead of the other, is that mainly what I think, and you guys can kind of help me on this one, is that for free cash flow up over here, we're using WACC minus G or R minus G for the continuing period. And the reason why we might use the FMM model is that if we are in a situation where we have a WACC that is less than our G, so then we have a negative value for that, and our results can kind of come out different depending on what it is, compared to the FMM equation down here. We're just using the multiple of FMM, which is EV divided by EBIT, and multiplying that by EBIT. So and the reason why the results might come out different, if I pull this up, and this might be kind of hard to see because it's small, but the reason why the results might be a little bit different is depending on if I can zoom in on this. we're using our observed, I don't know why that keeps, our observed multiple, or if we're using a target multiple, depending on what that is, in the present value of DCFs or the continuing value. As you can see, right here we have a target multiple of 20, so that brings these two results out higher. And depending on
Fred, we were unable to hear you there for a moment. Could you repeat that, please?
Yeah. So when regards to if we're looking at different value outcomes, if they're going to be similar or different between the two, FCF is going to bring, or FMM is going to bring about different outcomes depending on the multiple you're using. If you're using your observed EBIT or your observed multiple, or depending on what your target multiple is, your outcomes will be different because of that multiple you're using. So you can see here that using a target multiple of 20 brings larger outcomes than, say, if we use 15, or of the multiple we observe, they come out lower. So that's where the main difference between those two comes about.
Okay, what else would you like to tell us about this?
So I think I covered everything that I could really figure out for the most part.
Okay. Brandon, I think you're up with questions. What question would you have for Fred?
Yeah. Something I was looking at is, and maybe you'd be able to figure that out. What the target, when it says, we have the target for 15 and 20, what role does that play in the FMM model?
To be honest, I'm not totally sure how to answer that question accurately.
I was totally confused too, and I was going through these problems as well. So I was just...
Yeah, because I mean, it was kind of tough because I watched the video that Rick posted about it, and Rick, this is something that you kind of came up with. So I understand the functionality and how to do the equation, but I'm still I guess kind of sparse on the role of the multiple and its importance in this.
Okay. Well, so I can, I think I can pretty easily address this. So go ahead and unshare the screen so I can share mine, please. Okay, I think you're able to see my equations up here on my screen now, right? So I want to focus for a moment on that same kind of spreadsheet that that we just had up, and I'm using a Mira-Dravana case right now. But we see that the free cash flow model and the FMM model is what we're looking at, have a relatively similar value. I mean, it's just over $1 million difference, and when we're talking about $172 million. Just over $1 million isn't that big. It's we're at just over 0.5% difference between these two. Well, let's look at the effect of this multiple. Let's assume for a moment that our company didn't have an observed multiple of 5. That we looked at the EBIT for the particular period we're looking at, and we looked at the estimated value, and we saw that we actually had a multiple when looking at those for that particular year of 5.82. Well, what is that going to do if we plug that in here? We have 5.82. Well, that changes our value rather a lot for the FMM model, right? And that would suggest that at a 5.82 multiple, we end up with not only a higher value, but something else must be going on in order for that value to be higher. It's not just that we gave it a different number. There's something going on inside of that number. So we're going to think about and come back to that in a minute. More often than not, you'll find just the opposite. more often than not, you'll see companies that where these values are different, and it's that the value when applying a multiple is less than the value when applying the free cash flow. So let's model that. What if it was only 3? We observed this and we saw that it was only a multiple of 3 on the base year we did our observation, and that meant that the FMM model was, in this case, about $50 million, which is a lot of money. I don't care what your proportionalities are, about $50 million less than the free cash flow model. Well, I might look at this and say, yes, that happens to be the multiple that we can observe for our entity in the year in which we are doing our observation, our base year. But is that where we want our company to be? We can look at this and say, how do we determine where we want our company to be? And we can look at other firms in the marketplace that are like us and see what their multiples are and see if our multiple and theirs are comparable to each other. In many cases, they're not going to be. So we can say, okay, well, just because my firm showed that for last year, there might have been something happening that was an anomaly in my firm last year. Maybe my growth was low last year compared to others. Maybe and maybe it was low compared to the industry, or just the opposite. Maybe it was high. In which case, we use the multiple as a comparable tool and a tool to target some things. So when we looked at the example here from Fred, he showed us 15, I think, or so observed, and then a 20 target. Mm-hmm. So if I'm looking here, and if my observed is 3, I want to look at this and say, what would I have to do in order to improve it to a 5, which might be more similar to the rest of the industry in their observed multiples, and it certainly brings my value more closely into line. What would I have to do to get a 5? I know that having a 5 instead of a 3 will yield a $50 million difference in my firm's value, and that's not trivial. So what do I have to do to go about earning a 5 instead? And so that's the use of a target sometimes. What must be changed in my entity in order to bring the value into line? Okay, well, let's answer that. Here is the equation, the algebraic underlayment of this multiple. And the EV/EBIT here is the multiple, right? That's the 3 or the 5 or whatever in our case. Mm-hmm. But we know that it equals this equation on the right-hand side. Return on invested capital, cost of capital, growth, and tax. So what can I change here? Can I change my tax rate? Mm-hmm. Well, in today's market, not so much. It's 26%, right? As long as you've got a dime of a taxable income, you're going to pay 26% on it, state and federal combined, or very, very close to that. So there's not really anything I can change about my tax rate. Do we know anything that we might be able to do inside of the company to change our cost of capital? We do now. We've talked about financial engineering. We could perhaps re-engineer some of our capital components such that we change the cost of capital to then change our EV/EBIT. So if we wanted the multiple to go up, would we increase or decrease the cost of capital? Decrease. Say again? Who said that? I couldn't hear it.
I believe, wouldn't you want to decrease the cost of capital?
We'd want to decrease it. That's right. Mm-hmm. Yeah. I wasn't challenging you when you said, I just couldn't hear what you said. Okay. If I'm going to challenge you, there will be no question in your mind that that's what I'm doing. Okay. So that would work. And if I then decrease the cost of capital, then that's going to change my EV, and it's going to change then this multiple itself as well. Okay, we get that. Is there anything else I can change here? Is there a way that I can change my return on invested capital? What is that? That's no Platts divided by invested capital. Well, if I want to change that, since it's in both the numerator and the denominator, it's not immediately clear to me what the effect would be. I could mess with this for a while, I could tell. But I could change that, and it's going to change the outcome over here on the left-hand side. And so maybe I want to improve my return on invested capital. Well, I'm probably not going to change my invested capital immediately. So how do I improve the return on it? I negotiate for lower costs from my suppliers and my employees and my rent and whatever. That's going to improve my EBIT, which is going to improve my NOPLAT. It's going to improve my return on invested capital. Okay, that would be a way to change this. If I'm trying to get to a different multiple, I might change my return on invested capital. I might go about working inside of the company to improve my return on invested capital. And then the last one is G. Well, I would tell you that G and ROIC are correlated because G is the growth of my company. So if we're looking at this, Fred, if you want to improve your multiple, and you want it to be like other companies in your industry that you aspire to be like, then let's go about a growth campaign. And if we can change our growth, if we can improve our growth, it's going to improve the dollars of EBIT. That's going to improve our ROIC all by itself, perhaps, and that's going to help us with this number. So when we look at what was shown to us, excuse me, let me bring that sheet back up. When we look at what was shown to us is in a couple of columns, and one of them showing a target, then it's a management tool. If we say, I want to end up with a multiple of 5, currently it's 3, but if I can get it to 5, if I can get it to 5, it's going to improve my value by $50 million. What do we have to do to improve it to 5? It's no less a management tool than when we were looking at ROE using the DuPont identity, which breaks down ROE into its component parts and lets us as managers attack it so that we can change it. Does that help?
Yes.
There's one other element in here that I think is critical that we need to look at. Let me bring that sheet back up. I think, Brandon, you may have said that that this was a bit of an enigma to you as well. Did that discussion help clarify it all for you?
For the most part, yeah.
Okay. So there's something else you might want to consider. So I think this question asks you, how are they different or how are they the same? And so I think you can pull out the equation and you can do some algebra here. So what I've done is I've given you the free cash flow model equation and I've given you the FMM equation. And whenever I'm trying to help people understand how something is different or the same, I like to break it down and into an equality. Well, equality suggests how are they the same, right? But if I show you how they're the same, then I'm also pointing out their differences. So how do I break this down? Well, just as we were told, the first part of the equation is the same for each one. So if that's the case, we can get rid of the first part because they zero each other out, right? We can subtract that element from both sides of the equation. They zero each other out. Well, we also then look here and we say, okay, we've got the same numerator, or rather denominator. So I can go ahead and I should be able to multiply each side of the equation by 1 plus whack to the t, and that's going to get rid of these denominators, isn't it? I'm not going to do that at the moment just because of the way these equational structures work in Excel. But what we're left with is free cash flow at time 1 divided by WACC minus G being equal to EBIT times the forward market multiple. So now we've broken it down and said, okay, here are the parts of the equation that show our similarities and that show where the differences lie, and we've gotten rid of those elements that were our similarities. So now, how is FCF at 1 equal to EBIT times the multiple? And so you can go about discussing that. Under what conditions? And then you can use this little equation over here to help do that as well. Remember how we got to this equation. If I type in here, well, I don't want to do that. Let me pull it from somewhere else real quick. Stay with me. I want this one. And I want this. Remember that what I've just given you is part of the KVD model. And in this part of the KVD model, the numerator is free cash flow, right? Do you remember that when we took the excuse me, my mouse is just seized up. I don't think my screens have seized up. Are you guys able to, do you guys still have operations on your screen?
Mm-hmm.
Okay.
Yeah, we can hear you too.
Okay, and unfortunately, your images have similarly seized up for me. So this is not good news when this happens. I'm going to see if this will resolve itself. I'm just going to continue to talk to you for a moment. So no plat times 1 minus G divided by ROIC. Do you remember that that is actually EBIT times 1 minus the tax rate, which is no plat, times 1 minus G divided by ROIC? And if we want to find, and we know that when we take that divided by WACC minus G, it gives us some value, some enterprise value that we've called a continuing value, okay? Well, enterprise value is a form of continuing value. If I divide it by EBIT, then I get the EV-EBIT multiple, and I can divide both sides by EBIT, in which case, when I've done so, I am left with, in this numerator, I'm left with 1 minus T times 1 minus G divided by ROIC. And it's that equation that leads us to the right hand of the equation next to EV-EBIT here. So these have some algebraic foundations to each other. And you can discuss this with me from an algebra standpoint, and you can then describe what's going on in terms of firm functions when you do that. So that's another way of approaching this. Does that make sense?
Mm-hmm.
Okay, so I've had this this screen and system element where we freeze up once before, and I believe that I can go ahead and restart my system. You guys are all going to stay within the discussion, and then I can come back to you. So I'm going to try to do that. Stay with me. It's going to take me a moment to get beyond this. I'm going to come back to you, and hopefully you'll all be together. Bear with me.